Hello everyone. In this session, we will develop a data model for Salon booking. Salon booking is an easy to manage appointments or service booking system. A customer can register and create bookings for salon services. That's the idea of the application. What we need to do is we need to develop a data model to support the services provided by the salon. The customer should have the ability to view all the services along with the price of the service. Salon may have many employees. Each employee will provide some services. Customers should have the ability to view the employees of the salon and also what kind of services they provide and their price. Customer can create a profile and then book a new appointment. Customer can also make modifications to the booking. Customer can also cancel a booking that was made in the past. These are the set of requirements for developing salon booking application. The business rules and data requirements are hidden in these requirements. So we will have to read the requirements and understand it. And if we find any data specific requirement, any data need to be captured and retained, we have to have the corresponding representation in the data model. So let me open ERD Architect. This is the tool I'm going to use. We will go ahead with a SQL Server model. Okay, I have an empty data model here. You can use any data modeler of your choice, but if you would like to use the same tool, let me show you how you can get a copy of this. Go to erdarchitect.com and you can download a free version of the software by clicking here. Let me close this. And this is the data modeling tool. And let me go back to the requirements. So let's go through the requirements one by one. Service menu should display all services categorized. Service menu should display. So we need to model the services and then the category of services. How can we model the service? I will create an entity to represent a service. To identify each service, we will have a service ID. This is the unique ID to identify a service. And then let's have a service name. I will describe the service with a service name, price, description. Let's also have a image for service. Okay, these are the attributes that describe the service. And another important thing about service is that we need to have them categorized. How can we model service categories? One way to model service category is by having an attribute here. Let me try category. So this is a category of a service. So we can have category here. All services will get categorized into something. The advantage with this approach is this is simple because with every service you will be able to get a category along with. But the challenge is if you need a list of all available categories, you will have to visit all the services and fetch the unique categories. That is one challenge. Another problem is if you want to describe a category with more details. Let's say if each category has a description and an image or any other details to describe the category, we won't be able to include everything into the service. So what we will do, we will take another approach. Let me delete this. I will introduce another entity. We'll name it category and identified by category ID. Let's describe it with the category, name, and description. We can have a category image if needed. I will add it as well. So we have category entity and service entity. This is representing service and this is representing category of service. So each service belongs to a category and each category can have many services of that type. So in that situation, we need a category ID in the service entity. So let's have a one-to-many relationship between category and service. I'm picking a non-identifying one-to-many relationship that migrates service category ID here. So we have a category ID in the service, and this is the relationship between them. Let me go back to the requirements. So first we have discussed service menu should display all services categorized. And the next one is under each service, respective employees providing the service should be displayed with the name, photograph, and other services employee provide. So let's go and see. We do not have any representation for employees because the point it says that an employee provides some service. So when we select a service, we should see all the employees who provide that service. So let's have a representation of employee identified by an employee ID. Hold on. If you look at the data types, you will find n-varchar 100 for all attributes. So this is coming from a model settings. So if you go to model settings, the default data type can be seen here. So if you make it n-varchar 200, now you can find all attributes assuming n-varchar 200, a model level settings as a data type. We can go and provide appropriate data type for all attributes, but we will do it at the end. Right now, let's focus on attributes and we will do the data types at the end. Let me turn off the display of data type at a model level. So turn off data type. So we don't have data type. We have category and service. We have employee. Okay, we have described the employee, and what we know beyond this is that each employee may provide many services and each service may be provided by many employees. So the relationship between service and employee is a many-to-many relationship. Let me go and pick a many-to-many relationship here and represent that. This relationship indicates which employee provides what service. Let's go to the requirements. Customer can place bookings for one or more services. So we have represented services, but now we have a requirement that we need to represent the customer. Customer can place bookings. So what we will do, we will create corresponding representation in the data model. Customer. Customer ID. Customer name. Okay, this is the profile of a customer. Customer can place bookings for one or more services. So let's create a representation of booking. Since customer may create many bookings over a period of time, we will also have a booking ID to identify each of them. Okay, we have a booking entity. Booking is created by customer. So we need a customer ID in the booking. Let me create a non-identifying one-to-many relationship from customer to booking, which gives us the customer ID here. And a booking is made for a service. So another non-identifying relationship from service to booking. So now we have the service ID. An instance of this entity, booking entity. In other words, a row in the booking table represents that this particular customer created a booking for this service. We go back to the requirements. Booking can be made for a particular date and time. That's very important. When we make a booking, booking is made for a date and time. Service date, service time. Okay, booking can be made for a date and time. A specific employee can be chosen for rendering services based on availability, or it can be unspecified. So optionally, when we create a booking, a user can choose an employee who provide that particular service. So let's have an employee ID in the booking that indicates which employee will provide the service. So a non-identifying relationship from employee to booking. So this is an employee ID, which is a result of this relationship. And what is this role of this employee here in booking? This is the employee who will provide the service. Okay, so we have the employee providing the service. A booking is always created for a customer. So we need a customer ID. And so this relationship is not optional. So if a relationship is not optional, you can go to the optionality of the relationship and set it to false. And you can find the optionality disappears. And then the corresponding impact in the DDL or in the database will be that these foreign key customer ID in the booking entity will be non-nullable. That is the difference between making it optional or making it not optional. Okay, let's go on. We have created this attribute. We have created service providing employee ID in the booking. Booked services can be cancelled before entering the services. So we need to have a provision to allow cancellation of bookings. So at the minimum, we need a booking status. This status indicates whether a booking is open, closed, cancelled, or completed. So we will have a set of meaningful status for the booking. If it is cancelled, we will mark this cancelled. If the scheduled employee is not available at the time of appointment, another employee can render the services. We have discussed that when customer create a booking, customer can choose a service providing employee. So that employee ID is saved here. Now at the time of rendering the services, if that particular employee is not available, we can go ahead with another employee. It means this value in the foreign key can be even modified. We have a value, but it can be modified. So this is the result of a relationship, which is this is the relationship. So when we say the foreign key value can be modified, it means this relationship is transferable. So a transferable relationship can be documented by specifying transferability to true. So I'm setting it to true. So this relationship is transferable, and there is no impact of setting this property in the database. This is just for documentation at a conceptual level. Okay, so we have the transferable relationship. Now let's go ahead and say a booking can be created by customer via the mobile application or with the help of an employee over telephone. So booking can be created by a customer, or often a booking can be created by an employee of the salon. If you want to capture which employee created the booking, we can have another employee ID here. Let me create one-to-many relationship from employee to booking. And this employee, what is the role name of this employee? So employee ID we have, the role is booking created employee. So when we migrate attribute from one entity to another entity, It's extremely important that in the destination you provide a proper role name. An employee ID is self-descriptive here. We understand that's the ID of an employee, but when the ID of an employee is present in elsewhere, for example, in booking, we need to say what is the role of that employee here. Let me go back to the requirements. Service provider admin staff should have ability to monitor or adjust open appointments. So do we need any specific data requirements? Admin staff should have the ability to modify the information. We do not need to capture any new data elements to support this. Customer can pay online. Customer can pay online for the services at the time of booking or pay at Salon after the services are rendered. So in that case, what kind of data support we need to provide? We are not going to handle the payment mechanism here, but at least we will capture how much amount was paid and the payment mode. Okay, that's it. Let me right click on the diagram empty area and press layout. So this is the layout. Before we try to build the database, we have to make some changes in this conceptual model. So one important thing we have to do is we have to set appropriate data types, and we have to also resolve many-to-many relationships. If you look at this model between service and employee, we have a many-to-many association here. We need to resolve many-to-many association. How to resolve many-to-many association? You can right click and then transform to an association table. So once you resolve it, you will be able to implement that in a database. A many-to-many relationship, we cannot directly implement it in a relational database. In a relational database, you need to translate that into an association entity or association table. So service employee, each record in service employee indicates that a particular employee provides a particular service. So if you have a specific price for that service, we can capture it here. When a particular employee provide a service, if there is an exclusive price for that, we should be capturing it here. Let me provide an artificial key here. So employee service ID. Let me lay out again. So we do not have any more many-to-many association on the diagram. Now what we have to do is before we build this as a database, we need to provide appropriate data types. So have the diagram selected and then display data type, turn it true. Let me lay out again. Okay, so now we have the diagram with all the data types. Let's go ahead with the primary key of category. What should be the data type? I will set it as int. For category name, description, these are good. Category image, if you want to store the path of the image, this is good. Or if we want to store the image itself in the database, we have to provide the image data type. Service ID, service ID can be a number. So I'll provide it as int. Service name, price, we have to have a numeric value. I will provide numeric value with a precision 2. Description is good, service image. Booking ID, I will choose numeric 12. Customer ID, we have to go and change the customer ID here. I'll change customer ID to numeric 12, assuming a large number of customers will sign up. Customer name, email, phone. Employee ID, I'll make it int. Okay, so foreign keys will automatically assume the data type of the parent key. So we don't have to modify foreign key data types. So let's go and find out service date. Service date should be a date type. Service time should be time. Okay, good. We have the appropriate data type for all attributes, and we have all the tables and the relationship. We have all the many-to-many associations resolved. And what we will do next, we will build this design in the database. If you want to get DDL for specific objects, let's say if I want to see the DDL, how it looks like for booking, you can select it and press Control Q, and then take a look at the output SQL window. If you do not see this output SQL window, make sure that in view, this particular option is turned on. Then you see the output SQL. If you select all the objects and then press Control Q, you get all the objects here. These are all the tables. And immediately after table, we will have the primary key of the table. And then after all the tables, we have the foreign key references. These are all foreign key references. Okay, let's build this database. I can copy this DDL from here and directly take to an SQL client application, or I can directly dispatch these from this tool to the database. Let's create a blank database and send this DDL from ERD Architect. You may have a question. If some of the objects are not available on the diagram, how can we get the DDL? So generating the DDL in this SQL output window and dispatching to database is only one method. If you go to model forward engineer, you will be able to find all the objects in selection here. You can specific objects can be selected, and then some of the forward engineering generation options can also be selected. And then at the end of all the options, you get all the DDL. So for all specific objects, you can see the DDL here. And then DDL can be generated to database by clicking generate schema here as well. So here the action will execute all listed objects in the database. Do you want to continue? So here, this is another method to send all the objects to database. So let's go back to the SQL output window. We will dispatch it from SQL output window. Let me create a blank database. I'll name it new Salon. New Salon is the name of the database. So if you look at the new Salon database, this is empty. We don't have any tables. From the ERD architect, we will send all these DDL by clicking here. Right click anywhere here and generate. This is SQL Server connection dialog. I will select new Salon. New Salon. Press OK. All these statements will be sent to the database and the result will be displayed at the bottom. If there were errors, we should be able to see them here. Let's go back to the database. Here we can see all the tables created. Tables, columns, corresponding data types, constraints, keys, primary keys and foreign keys. And we find all of them in the database. Now we can insert data into this database. We can retrieve that and we can support Salon booking application. Thank you.